Hi everyone, welcome back to my channel. In the last video, we have learned how to solve an exact differential equation. In this video, we will be dealing with non-exact differential equations. First, we will find an integrating factor. Multiplying by that factor, the equation will be converted to an exact ODE. Okay, so now we will discuss about few rules to find the integrating factor. So let m dx plus n dy is equal to 0 if the given non-exact ODE. Then since it is non-exact, so non-exactness implies that del m del y must be not equal to del n del x. So here we have the first rule, rule number 1, which says that if 1 by n times del m del y minus del n del x is equal to a function of x, then e to the power phi x dx is an integrating factor. So that means we have to calculate 1 by n times del m del y minus del n del x. And if it is a function of x, then e power integral that function dx is an integrating factor. So let us understand this rule by an example. So take x square plus y square dx minus 2xy dy is equal to 0. So here we have m is x square plus y square. So that means del m del y will be 2y. N is minus 2xy. So del n del x is minus 2y. So clearly del m del y is not equal to del n del x. So it's a non-exact ODE. And what is the difference? Del m del y minus del n del x is nothing but 4y. And if we calculate, what will be 1 by n del m del y minus del m del x? This will become 4y by minus 2xy, which is nothing but minus 2 by x, which is our phi x. So by this rule, integrating factor will be e power phi x dx. So what is phi x? Minus 2x 2 by x. So it is minus e power minus 2 ln x, which is e power ln x power minus 2, which is equal to x power minus 2. It's a simple logarithmic calculation. So we have integrating factor x to the power minus 2. Now we will see how by multiplying by this integrating factor, this equation become exact. So multiplying by x to the power minus 2, we get, so it will be 1 plus y square by x square dx minus 2y by x dy equal to 0. So here we have m is 1 plus y square by x square. So that implies del m by del y will be 2y by x square. N is minus 2y by x. So del n by del x is nothing but 2y by x square. So hence we have exact equation, and we know how to solve exact equation. Okay. So next is rule 2. If 1 by m times del m del y minus del n del x is equal to a function of y phi y, then e power minus phi y dy is an integrating factor. So take an example to understand this rule better. So suppose 2xy dx plus y square minus x square dy. So this is our m, this is our n. So what is del m del y? 2x, and del n del x is minus 2x. And what is the difference? Del m del y minus del n del x is nothing but 4x. And if we multiply by 1 by m, so it will be 4xy, 2xy. So it is 2 by y. So by the rule, the integrating factor if will be e power minus phi y dy. This is e power minus 2 by y dy. This is minus 2 ln y, which is nothing but y to the power minus 2. So y to the power minus 2 is an integrating factor, and if we multiply by y to the power minus 2 in the equation, then we will get an exact ODE. You can check that in your own. Okay, now come to rule number 3. Suppose we have equation m dx plus n dy is equal to 0, and here we have m is of the form y times a function of xy, and n is of the form x times a function of xy. Then 1 by mx minus ny is an integrating factor provided this mx minus ny non-zero. Okay, so let us take an example. So suppose the problem is y times xy plus 2x squared y squared dx plus x times xy minus x squared y squared dy. So note that here we have y times f1x, sorry, f1xy, and this is x times f2xy. So here we have this kind of equation. So by this rule number 3, we have the integrating factor will be 1 by mx minus ny. So if we calculate this, we have 1 by what is m? Y times xy plus 2x square y square minus ny. So we have xy times xy minus x square y square. And if we simplify this, we will get 3x cube y cube. So integrating factor is 1 by 3x cube y cube. Okay. So next come to rule number 4. So if the equation m dx plus n dy equal to 0 have the following form, where both m and n are homogeneous function of x and y of same degree, then 1 by mx plus ny is an integrating factor provided mx plus ny is non-zero. So it is saying that if we have equation m dx plus n dy is equal to 0, where the both m and n are homogeneous function of x and y of same degree, then 1 by mx plus ny is an integrating factor provided mx plus ny not equal to 0. Okay. Take an example. So suppose x squared y dx minus x cube plus y cube dy is equal to 0. So note that here m is nothing but square y and n is minus of x cube plus y cube. So note that both m and n are homogeneous of degree 3. So by this rule we can calculate what will be mx plus ny. So which will be x cube y plus y times minus x cube plus y cube. So it will be x cube y minus x cube y minus y4. So it is minus y to the power 4. So minus y to the power 4 is an integrating factor. So that's how by this 4 rule we can find integrating factor for non-exact differential equation. And after finding integrating factor, we will multiply that factor and then we get the equation becomes exact differential equation and we know how to solve exact differential equation. So that's it for today.